Yeah, we will see introduction of this Apache Spark. So, who wins, Apache Spark or Hadoop? So we know that Hadoop has two main components. One is for data storage, HDFS, and to process the data, one process model called MapReduce. So entire Hadoop, works on these two, HDFS and MapReduce. That's what we have seen. And even when we are learning this Hive, Pig, and Scoop and other technologies also, we have seen that MapReduce concept, everything works on MapReduce. So Hadoop understands MapReduce without even investigating how that particular job is optimized or whether we can have a kind of a logical plan or physical plan. Nothing. It will not care about anything. So it just runs the job, MapReduce job concept, and Hadoop depends on it. So we will see who wins, whether Apache Spark or Hadoop. So I'll just go to the homepage of Spark. That he claims that lightning fast unified analytics engine. So how they will achieve this lightning fast, we will see. And also it says that it is a unified analytics engine for large scale data processing. Again, how this Spark will do this, how this Spark will process large scale data processing. And you can see one more thing. So runs workload 100 times faster. So Spark claims all this on their website itself. So we will see how this can be achieved. And one more thing also, coding. Coding is something that you can do minimal coding. So Spark supports Scala, Python, and Java, and sometimes R also. But these three languages it supports. Means like a Spark is a framework. Basically, Spark is a framework where it comes with some components. So components are like, you can see here, Spark streaming, SQL and data frames, and MLib and graphics. So we will see one after one. So first, now we will understand who wins, whether Apache Spark or Hadoop. So I want to highlight here one thing. So Spark won't have any storage. It will mechanism or the idea behind using Apache Spark is to process the data. I mean, you can process the data faster way. That's all. It won't have any storage. Now we will see few comparisons with respect to Hadoop and Spark. So with respect to storage, yes, HDFS is the main storage device for Hadoop. Whereas for Spark, there won't be any storage device. It will just make use of existing HDFS, means it works on top of HDFS. It leverages the existing environment, so it won't have any storage. The other one is yes, MapReduce concept. We know that Hadoop make use of MapReduce concept effectively to process the data. So it is a data model. So whereas Spark, so most of the people say that Spark won't work on MapReduce. No, it is not correct. Actually, Spark also works on MapReduce concept, because in Spark also we have a concept called MapReduce by MapReduce, reduce by key, group by key, and reduce. So many transformations are available. We call them as a transformation. So when this transformation executing, so it will use indirectly mappers, reducers, and shuffles. So that's why we should not say that MapReduce is not a part of Spark framework. Yes, Spark will use MapReduce, but the style of execution is little different. So now we will see speed. So speed, yes, we have seen that. Of course, it is a fast. When you are processing large amount of data, like GBs or TBs of data, obviously you will see some speed in the Hadoop. But if you see the statement that he is claiming, so Spark is even faster than any other process. And if you see, they have given some graph also. Let me explain this later. So Spark will run 100 times faster than the other frameworks, and then they have some mechanism called DAG scheduler, query optimizer, and a physical execution engine. We will see that. So with respect to resource management, again, so Spark can work on standalone. So standalone resource manager is available. If you want to run a Spark job, you can run on a standalone, which means like Spark can make use of its own resource manager, or else you can still use the AN. So we know that AN is something that it's a resource manager. So you will have a machines, dedicated nodes, and when you are submitting a MapReduce job, what will happen? So it will identify what nodes are available to process the data, and it will split the work to nodes in order to process the data. That is the idea of AN. So Spark not only works on its own, it can also work on AN. So this is just difference between this Hadoop and Spark. So I think just now Kalpana has joined, so I'll repeat it again. So Hadoop has its own storage mechanism called HDFS, whereas Spark has Spark has nothing. There is no storage area for Spark. So but it can leverages, it can work on HDFS.
Raja, I'm so sorry. See, I just want to understand what is Spark.
Yeah, Spark. So Spark is something that it's a framework, Spark framework we have. So we were discussing about the differences between Apache Spark and Hadoop. So like how you have a Hadoop as a framework. So Spark is also another framework which addresses few challenges that we have in the real time. We will see that. So I was just getting few details of differences between Hadoop and Spark. So the main aim of Spark is to process the data, but not to store the data. So that's why I was mentioning Spark is a processing engine kind of thing. And it works on top of HDFS, HBase, and Hive as well. And it also has a MapReduce concept. That's what I was telling. MapReduce concept it uses. So there are transformations. So we call transformations and actions. So transformation is something that you want to transform the data from like one format to another format, which means like whether you're cleansing or you're filtering, aggregating. Okay, so these kind of operations will be performed here in Spark. So for that operations we use MapReduce concept. And the speed, yes, when you are dealing with huge amount of data, already Hadoop proven that it can process the data, which is a computation model, MapReduce. With the help of MapReduce, it processes the data fast. But even there are some challenges where Spark can address this, and Spark is like 10 to 100 times faster. That's what they claimed on their website itself. So I was on the website, Spark website. So they mentioned lightning fast unified analytics engine. And also you can see one more claim that they mention on their website is a unified analytics engine for large scale data processing. And they made it here also 100 times faster. So with the features like DAG scheduler, query optimizer, and physical execution engine. And if you see here, there is one more graph they mentioned. So logistic regression is something that they mentioned. You see here, logistic regression, which is a machine learning model, logistic regression. So the idea of logistic regression is that, getting the output from a binary variable to set of input parameters. For example, I can say age, gender, and then smoke habit. Based on these three parameters, you can decide whether the person like live or death. Like you can estimate. So here they use that same logistic regression. So logistic regression is something that it is a kind of iterative model. So they will keep running in order to get the proper output. Because it's one shot, you cannot get the output. So they compared these two, and if you can see here, it is faster almost 110 times. All right. So I was telling the components available. This is the component Spark SQL, streaming, MLib, and GraphX. This is a Spark framework we call, and these are all the components available. So Spark supports working with Java, Python, and then Scala. So Scala is a language. It's similar to Java. So it's built on top of Java only. So we will see how that works. We are not going to work with Scala, but I'm preferring PySpark. So PySpark is again.
Okay, Raja,
Yeah.
coming to Scala,
Mm.
Srini is actually expecting some Scala things.
Okay.
So maybe like covering basics of that. Maybe Srini would be happy with that.
Okay, no problem. Scala.
It's just not from us. Like Srini is expecting that.
Okay, no
The
problem.
last
Scala.
time when I called it.
Yeah, no problem. We'll see the Scala then. No problem. PySpark you can learn, right?
Maybe like can't we go with like in depth of one and a small introduction of other?
Okay, sure, definitely, yeah.
I mean, like if you, as you're saying, Python is
Yeah.
like very important with other things. We'll go in depth of that, and we can go on intro to Scala.
Sure, definitely, yeah. So that's all about the differences between Hadoop and Spark. Let's see. I have a few more things. So that's what I told. Spark, it has its own cluster, standalone cluster. So where it can run their programs and the data, so that can consume from HDFS, Amazon S3, and HBase. So it can get the data, it can process the data. So it gets the data and then process it and then store it back to HDFS, S3, and HBase. So what I wanted to say here, it won't depend on R. Basically, it has its own cluster, management cluster, okay, standalone cluster. Yep. So that's what I was telling. Spark has its own cluster, and Hadoop, like Hadoop also, it has its own cluster. But it is suggestible if you are installed already a Hadoop, so make use of this Spark. So you can set up Spark on top of your existing. There is no need to specify any extra cluster or a separate cluster for this Spark. You can still make use of that. So to reduce the no cost and no data locality means like again, say for example, if you want to set up the cluster for differently, like for Spark and for Hadoop, so you need to make a copies of these files from one location to other location, again from HDFS to this Spark cluster or Spark cluster to Hadoop cluster. So better you can make use of this Spark on top of HDFS existing Hadoop system. Okay, so now we will see. So Spark can work on Hadoop, and cost-wise also it is simple. Like it's a coming as an open source product, and it leverages both HDFS and you can make use of this HDFS and so that you can also process like distributed wise. You can set up n number of nodes, and you can specify n RAM and then memory and hard disk. So now,
Raja, we lost you in the middle. Can you repeat the statement?
Yeah, see, nothing. So what I wanted to highlight here is like Spark can work on Hadoop. Spark can work on Hadoop, and with that you can avoid some cost, and then you can, yeah, it leverages the HDFS and concepts. So it can make use. So it can read the data. It can process the data on HDFS. Also, it can also work with AND resource. So does Spark replace Hadoop? Definitely, it's not a replacement. So Spark is a kind of enhancement and definitely not a because it's own. I mean, say for example, if you're already having some MapReduce programs, because Spark introduced recently, but MapReduce concept is available since 2010 or 11. So they started working with that computation model. So what people will suggest, not to replace everything. I mean, no need to rewrite all this MapReduce code, but identify which jobs are running very slow and time taking process, then try to target those to convert into Apache Spark, and whatever new data models or data processing engines that you are going to create, you can make use of Spark. So that's what experts suggest. So they say that it is not at all a replacement. It is just an enhancement of your existing computation model, MapReduce. Okay, so now we'll see what are all the challenges that Spark tries to address. So especially Spark solves, okay, inefficiencies that we have in two areas. So one is interactive iterative machine learning and interactive data mining. So what does it mean? So iterative machine learning is something that just now I've given some machine learning algorithm. So it is especially useful for data scientists where they cannot wait for hours and hours to process the data. So when you go with MapReduce concept, and there are situations where you need to run a model, data model, iteratively, like multiple times in order to get the proper output. For example, logistic regression, that also we will run iteratively. So when you want to iteratively apply some processing, because you're applying some data processing and you're running same program again and again. So we know that big data works on MapReduce, and we know that it will store intermediate results and then blah blah blah, so which will make some delay. It's not like efficient, but data scientists won't wait for long hours. Okay, so that's why Spark came here, and then it has its own features like in-memory computation, especially. And with that in-memory computation also, it works on distributed. So distributedly in-memory computing, that is the unique feature of Spark. See, there are many other applications also which runs on in-memory computation. For example, if you take Oracle also will work on in-memory computation. So it will store the data, metadata, and data cache, everything. It has its own features. Okay, but still, what is the difference is, I mean, uniqueness is here, distributedly in-memory processing. So Oracle will not process distributedly. It will have only in-memory. Even our laptop also is working on our RAM. So every time you boot up, so RAM needs to do that. If you take out RAM, our laptop will not work. But what is the specialty? Distributed again. So we don't have that in environment. And so here what I mean to say, when you are running a process or a data transformations you are doing, and if you want to have a iteratively, so that iterative may consume the time when you are doing a normal procedure like MapReduce program. So if you do this Spark, so this can be improved. The other one is interactive data mining. So interactive data mining is something that you are working with some e-commerce website and you wanted to make some improvements to the site. And when you are making some improvement to the site, you also need to estimate how that particular improvements are benefiting into getting increased sales. So that is interactive data mining. So when you are analyzing this kind of data, if you apply batch processing, which is MapReduce concept, it will be a time taking process and you cannot mine the data interactively. So when you process using Spark with the unique feature, so it will be faster. That's all. So these two are like Spark addresses that we have some challenges. You got it, guys? Or you want me to repeat again?
Just the last part.
Yeah, in interactive data mining. So interactive data mining is something. Data mining is something that what you are pulling out the meaningful data. That's all. I mean, more meaningful data. And when you are doing this, is kind of interactive. Interactive means like I take the example as e-commerce websites where you wanted to you wanted to build a suggestion engine. Like you need to implement one model where it goes and based on user interest, based on user preference, so you need to make some suggestions, like you buy this product and you go with this product. If you go with this product, this much discount you will get. I mean, you go with this card, you can get this much discount. So these kind of suggestions you want to make one model. So this model, when you can apply to the e-commerce website, so you need to also identify how my data model that which I implemented to improve the sales, so how it is working. And you need to know interactively, and you need to extract the data and understand, okay, how many sales I have applied this model today, how many sales increased by tomorrow after implementing this kind of interactive data mining. If you want to do with MapReduce, just imagine it's a time taking process because it has to run MapReduce, it has to store intermediate results. Again, it has to process again intermediate results if it is required. So that's what Spark will address all this by calculating the results in memory, and that too fast because it has been distributed across clusters. So the unique feature of Spark is not only in memory computing, it also works distributed manner. So that is the main difference between the other processing systems and Spark, where it got that demand. I mean, they claim that 10 to 100 times we are faster. Why? This is the concept. Clear, guys? Kalpana, you.
Yes, Raja.
Thanks. So now, that's what I'll just give now. I'll just give now simple example how this Spark can eliminate the dependency where when you go for iteratively. So now I have people like you are the one so connected on Facebook. So you are connected to Sam and Emily is connected to John and Riley is connected to Jim and Steve. So now the thing is here, the connection from you to Steve has a separation has a 2 degree. So degree of separation is 2. So if you want to find out whether Facebook needs to make suggestions like this guy is your friend, can you connect? So to do that, they will run one algorithm. So when they run algorithm for the first time, so you are connected with the Sam and Emily. So that will understand, the model will understand. Since I'm representing here already in a graphical way, so it is clear that you are in 2 degree separation. But when you have a data in text and that too randomly records are available, so you want to apply the same thing. Okay, if you want to run a model, it is not possible with one time. So you have to run for multiple times. So in this case, you need to run the model at least for 2 times. So when you do this particular problem statement with a regular model, so it will take time. That's all. That's what I wanted to highlight. So when you use this Spark can do it in memory, and then that too it will be faster. So we will see that in the next one more slide with a clear example. So now what will happen? Let's take iterative machine learning with Hadoop. So first you will get the input, and with the Hadoop MapReduce concept, you are going to generate some mappers or reducer shuffles, whatever. So it has to store those results in HDFS for sure. Again, you want to run same model with some different parameters. Again, if you run it, so again it will run and then store the results in the HDFS. So that's how it will work. So every time MapReduce will store the results inside the HDFS, which is it writes and then reads the data from the disk, and finally it produces some output. So now when you see Spark, it will not really store the data, it will just get the data from HDFS, that's all. And once it gets the data, and then Spark, it will process it, and then it will not store into the HDFS, but it will store into the memory, which is RAM for us. Again, it will process. If you want to further process, if you want to further iteratively run the program, then you can make use of, again it will be written into RAM only. So it will not go to HDFS. Due to this feature, so read write time will reduce, and then you can process the data in a faster manner, that too distributed way. So that is what iterative machine learning with Spark. Clear, guys?
Okay, so instead of having distributed hard disk system,
Yeah,
we do have distributed RAM based system.
exactly. So RAM. So memory, in memory computing, in memory, we should say in memory. Yeah.
Okay.
So that's what I was telling. In memory computing, it's not at all a new concept. Every machine that works in IT, like a laptop or mobile, everything has a memory. But the problem here is like no machine serves in this manner, distributed scale. So you can keep add on your resources, and that works faster. So in memory computing with distributed manner, this is the unique feature. All right.
Okay, Raja.
Yeah. So now how this will work, Spark execution engine. See, no one will cover all this, but still I wanted to make you clear. So I'm taking special interest than other technologies like Hive, Pig, or HBase, because this is something that we are using effectively in the markets. So Spark execution engine specialty is it will just read the code. It will get the code from user. Now I'm submitting some code. So Spark has the capability to make a logical plan and then physical plan, and then it splits up into tasks. Then it will submit to the Spark cluster. So that's how it works. If you take Hadoop and you are composing some MapReduce job, and when you're trying to run that job through Hadoop, it will not care about what you written. It just simply triggers what you've written. That's all. So it will not prepare any logical plan or physical plan, and it will not split also. The job in Hadoop is just to trigger the job. Whatever the job composed by the user, irrespective of whether it is a bad design or good design, it won't bother about that. It won't go for any optimization also. It just simply triggers that. So based on the slowness of your output or how good your program is doing, so you can just redesign. So that is the option. But when you come to Spark execution engine, so when you're writing it, so it will prepare a logical plan and then physical plan how to execute, and your program will be split into tasks. So task means something that subset of your code, and then it will submit to the Spark cluster. So that is the specialty of Spark execution engine. So when they say, when someone is asking what is the advantage of Spark, don't just say that in memory computing, because they kept reading about this in memory. So they say that in memory computing. No, not at all in memory computing. The specialty of Spark is not only in memory computing, also execution engine, the style of executing a program. So now it has a concept called resilient distributed data sets. So it is core of Spark. I jumped quickly here. I'm not sure. Let's skip this. Yeah. So these are all other, okay, that's why. Yeah. This is another feature that we have, resilient distributed data set. We call it as RDD. So this is core of our Spark framework. So RDD, it will enable Spark to keep track of all operations and transformation. What does it mean? So you are reading or else I'll explain this in the next slides. That will be easy. So RDD, you just make note.
పవర్ పాయింట్ రా అని రే అది పవర్ పాయింట్ అని చెప్పిన ఎక్కడంటే అక్కడ కూర్చోకూడదు.
Yeah, sorry, Kalpana, you are unmute.
I'm sorry.
Yeah, no problem.
I'm sorry. Yeah.
So yeah, Spark, exactly. So we were discussing about the RDD. So RDD is something that resilient distributed data set, where it is kind of core for this Spark framework, and it enables Spark to keep track of all operations and transformations. So what does it mean? We will see in the next slide how it will track operations and transformations. So the next one is, yeah, Spark architecture. So Spark architecture is built in order to improve the speed and efficiency comparatively other frameworks. Spark architecture. So these are all four lines that which makes Spark different from other processing engines in memory computing. So don't say that only in memory computing. You can also add that Spark execution engine. So what is a Spark execution engine? That it prepares a logical plan and physical plan, and then it splits into tasks, and then it will submit to Spark cluster. So that is that. And resilient distributed data set is something that it is a collection of data basically, and it is a kind of immutable. So you cannot make any changes to the RDD. So RDD is a kind of resilient distributed data sets. Then Spark architecture. So they designed Spark architecture in such a way improvement will be like anything. The performance improvement will be faster. So now let's see how this works. RDD, we will look into RDD, so which is core of this part. So in real time, so you have input data set on HDFS. So when you are trying to compose a program, compute a model, MapReduce program, so what will happen on each block? MapReduce will start, and then you see here node 1 to node 5. So node 1 to node 5, and they start processing the data. And intermediate output, we know that when done with this first phase, the data will be stored inside the hard disk like HDFS. Then again, MapReduce job, you have further computations. Then again, they will compute node 8 to node 10. So node 6 to node 10, the output of these particular nodes will be input for these nodes. Now, for example, node 2 failed. So node 7 is actually waiting for the input from node 2. But unfortunately, due to some crashes, so it failed. So node 2 failed. So what will happen in this case? HDFS has intimate results. So fault tolerance will be like this. So the node 7 will get results from hard disk because it already stored, it processed it. Otherwise, even if it is not, then what will happen? Node 2, when node 2 fails, node 3 will come and pick it up, whatever the data available in node 2. So that's how the fault tolerant is available. Now we are discussing with in-memory computing, right? So now data will be not available on any of the disk. So it will not store any results to disk. Now in this case, what will happen? So for example, if the same case, node 7 is failed in the second layer. So node 7 is failed, but node 7 is dependent on node 2's output. But node 2 output is stored in memory, which means that the results are in memory. And when node 2 fails, how to recover that result? This is a challenge, right? So now we will see how this particular challenge can be overcome here in Spark. So I'll take one example. Let's leave about everything. You forget everything about programming and Spark. We are not dealing with that now. So we'll go to one example. So here, what I'm doing is I'm giving a piece of information like 10 to John. So John is his duty is to add plus 10 to that particular input, whatever input I give, not only 10. So his duty is to add 10, and Emily is to add 20, and Sam is to add 5, and then Riley is to add 40 finally, and then she has to write the output to someone, like final output she has to give. So now what will happen in the process? Sam has become like unreachable. So he's not reachable to Riley. So what will happen? Now you see that this is a programmatical representation. What A is the value that I'm giving, 10. And then John knows that B equal to A plus 10. Similarly, C has its own calculation. D also it has its own calculation. And E, finally, E is having that calculation. So now Riley is asking whether Sam is available or not, because she needs input from Sam only. Just think that these are all like data nodes, but let me explain how they will work. So now when Sam is not available and he's not responsive, maybe he's sleeping or he's out of his desk. So now how to get that data and then execute it, because user needs in output, because he has given some 10 and he's expecting for output. So now in this case, what will happen? Here is the speciality of Spark. So it immediately assigns a new member. Okay, it assigns a new member called Jim, and then Spark remembers what operation needs to do. Okay, so at the John level, what kind of operation it has? A plus 10, Emily B plus 20, and Sam C plus 5. So Spark has a track of all the operations that are happening. So with this feature, so what will happen, when a particular node is become unavailable and not reachable, so it has the track of operations what Sam was doing. With that, what it can do, it can get one more person help, one more data node help, and it says that, hey, this operation needs to be performed here, and we got the output from Emily. So can you do it for me? Yes. The other data node will take care of that responsibility since the piece of information is available, and then the output will be passed to Riley. So which is like 40. And then she calculates 40 plus 40, 45 plus 40, and then it will give to next level. It will write the output. That's how RDD works. So RDD enables Spark to remember what happened at particular point of not time, at particular point of task. So it remembers. So that's how when it fails, now when it fails, okay, immediately the other data node will come and pick it up. Okay, node 2 failed, so node 1 will come and then process it again, and it will give it to the node 7. That's how it works. RDD is a core of the Spark. Guys, any confusion here?
Not for me, Raja.
Clear?
Yes, Raja. I'm
Okay, Kalpana, how about you?
Yes, Raja.
Yeah, great. So this is all about introduction to your Spark. Then we know that yes, we have some components: Spark SQL, Spark Streaming, MLive, and then graphics. So Spark SQL is a traditional way of dealing with your data. So again, we have RDD and data frame and data set. So we do read the data from HDFS, HBase, Hive, and we will process the data, the same operations. If you want to filter out the data, and if you want to apply some aggregates, and if you want to do some joins, all these operations can be done in Spark SQL. So Spark streaming is something that, you have some streaming application. For example, I will give real time example. So yeah, e-commerce site. So it will be keep fetching the data. So it will definitely store it somewhere, and you need to pick it up as soon as the data arrives into a particular location, whether it is a Linux machine or whatever S3. So you wanted to consume the data and then process it and then send it to the next layer. So that's how streaming works, like online streaming data. And MLive is something that if you want to work with machine learning models, yes, Spark also provides features to work with machine learning models. And the other one is graphics. If you want to analyze the data using graphics, you go for graphics. But remember, only Spark SQL and Spark streaming we use majorly, and those data scientists will work with MLive. Clear, guys?
okay, Raja.
Yeah. So now what I wanted to do, I want to continue tomorrow. I wanted to stop it here because no need to create much confusion in the day one itself. So tomorrow we will start working with Spark. So we will launch this Spark shell, and what are all the ways that we have to discuss with this Spark. Yes, so we go with Scala only, Spark Scala. And for introduction purpose, definitely I will cover Spark, PySpark also. Okay. So when I say PySpark, so we are working with Python. So when I say just Spark Scala, so it is a programming language Scala, and we are definitely not going to work with Java because you need to write so much coding in Java. So I prefer these two. Okay, guys.
Do we need to have any basic knowledge on Scala? Because
Yeah, just base knowledge means like even if you are, let's see the syntax what we use are not really difficult in Scala, very simple. And I don't think I can compare this with the Java, but I can compare Scala with Python. Little similar, the programming style.
okay.
Okay. Yeah. So that's all I wanted to have in this session. So I'll continue from tomorrow coding the Scala and then a combination with the Spark.
Okay, a small request to
Yes.
both you and Kalpana too.
Yeah.
Okay, so tomorrow